Hello friends, today I'm going to talk about Leetcode-201 bitwise and of numbers range. Given a range mn where m is less than n and between 0 and 2, this is actually 2 powers 31 minus 1. Return the bitwise end of all numbers in this range, inclusive. So here is the example. We have 5, 7, and we need to return the bitwise end of all numbers in this range. That is, we have to bitwise end 5, 6, and 7. So we get the numbers 4, and for this second example, we get the input 0, 1 and get the output 0. So naively, so we can have the 5, 7 and so m and n. So we can iterate m to n, right? And get the bitwise to the end, like all the numbers should be and I. This takes the big O n minus m times. For this problem, it could be time limit exceeded because the mn is in the range of 2 powers 31 minus 1. So this is about 10 powers 10. It's about 2 times 10 powers 10. So we have to think about another solution. The second is we need to consider the properties of the bitwise n, because we know that if the 1 and 1 equals 1, 1 and 0 equal to 0. So as long as there's a 0 in the bit in that bit, the result is always 0. If the result is 1, then all the bits should be 1. So we can iterate all the 32 bits and use a numbers to get the bit numbers. For example, the bit numbers currently equals 1 indicate the least significant bit 1, and then we iterate the numbers from range m to n again, and check whether the bit numbers equal to this to I equal to 0. If it is 0, it means that we have get the answer is answer 0. So we do not need to do the rest operation. So we just directly break. In this way, we can save a lot of time complexity. But for specific time, that it depends on the range of the mn, but it cannot above these levels. And this the second way that we can optimize again. That is, we can find some patterns here. The pattern is that, for example, here is 5, 7. and we get the bit number is 5 is 0 1 0 1 0 1 and 6 is the 6 is 0 1 0 1 1 0 and 7 is 1 0 1 1 1 and we found that actually because this first bit it has 0, so the answer is 0, right? Because it has 0, and the second bit it has 0. Here is 0, so the answer is 0 0. And for the third bit, it has 1 here, so answer should be 0 1 and 0 0, right? So the answer is 4. So we can find that it has some pattern that it only depends on those. This is depends on the first second bit. Actually, depends on this bit. So actually this is 0 and 0 is the same. So we will find that is m and the value equal to n. So we need to compare this. This is the trick part here. And we only need to compare whether m and n. We do not need to compare this 6. We compare the whether if m equal to n. If it's not equal, we just shift by 1. So we then compare 0 1 0 with 0 1 1. This is not the same. They're not equal. Not equal. So when then we shift right again. Then we compare 0 1. Is shift 1 is 0 1. That's a mistake here. This should be 0 1 1, right? And then we compare it. This is equal. And after is equal, we will stop. Then the final answer will be 0 1. Then shift left the number of the previous shifted number. So this is the way we can. In this way, we can only get the. We only need to get use the m and n. We can, if the this example is not obvious, we can use another example. For example, 1 is 9 here, and if 1 9, we get the numbers 0 1 0 1 0 1 1 0 6 7 8 9, right? And we also find that we only need to compare these two. So because actually the answer for this is I think the answer for this should be 0, right? So we compare this m and n. If m is not equal, we need to shift right by 1. So then we'll compare 0 1 0 equal to 1 0 0. This is not equal. So we'll then shift again 0 1. Compare with 1 0, and they are not equal. Then we'll shift again 0, compare 1. They are not equal. Then we'll shift again. So there are 4 times shift. So we will shift M over 4 times left, so equal to 0. And this here is shift 2 here. 0, 1 shift 2, then we get 0, 1, 0, 0 equal to 4. So this is a elegant way to shift numbers. Let's write the code with this way. In this way that we just get the shift count initialize 0 and then use a loop to decide whether m equal to n or not. If it's not equal, we shift right by 1, and also n shift right by 1. Then we get a shift count. So then we return the m shift by the shift count. Okay. Yeah, we made it. Thank you very much for watching. If you like the video, please subscribe it.